Hello everyone. In this video I would like to show you Haiwell PLC programming features. We are going to create two applications, one for AC series PLC and second one for T series PLC. AC series PLC is going to have RTD, temperature sensor and some push buttons connected to it. Engineering value of temperatures that is connected to AC series will be transferred to T series PLC via Ethernet using a Haiwellbus protocol. Temperature will be sent only if push button in AC series PLC is pressed. So let's start with creating program 1 for AC series PLC. So our PLC is AC and CPU type is AC10C0R. We will call our program PLC 1. And the program's called main. Okay, so we will start with hardware configuration. We must add our temperature module. In our case we use A04RC. Okay, we have four basic resistor types: PT100, 1000, CO50 and C100. We will use a bit different type, so we'll set it up to PT1000 and we will turn off engineering scaling to engineering units, and we will scale it inside the program. Okay, so our hardware is done. Then we might create our tags. So we'll start with our push buttons. So our first push button will be start, another one is stop push button, and one output, digital output, is send data to other PLC. And also we'll declare our analog input AI0. So this is raw temperature reading. Okay. Yeah. So we will start our programming with creating a sub-program. In this one we will scale our temperature. So we'll call it scale temp. Inside the program we will first add a scaling function that is called SC. So our input is AI0. Engineering range or engineering raw values of the analog input is from 0 to 32,000, and from resistance characteristics of the table of our sensor we know that it will be scaled between minus 50 C degrees to 30 C degrees, and we will save scale value in some placeholder in register V1000 for example. Then in new network we must convert this value to from integer to floating point. So we'll use ITOF function V1000 to V1001 for instance, and then we have to divide it by 10 to get the actual value. So again, floating point instruction and FDIV here. So we divide V1001 by 10, and then we get our real engineering value. So we'll save in V1003 here, V1003. Okay, so here we should get our engineering value. We'll create now another sub-program. We'll call it in and out. This one will also have some parameters, components. It will have two inputs, start and stop, and one output, send. Okay, so inside this program we will declare some actions. So if we press start, which is LM0 inside our program, we will set a help bit, might be M0 for instance. Then if we press reset stop button, LM1, we will reset. Our bit M0. In new network, we'll make a conditions to send or not send our engineering value to second PLC. So if M0 is pressed, we will activate the output, LM2. Also, we will move our V1003 value to V1005, which will be our output to the other PLC value. But if the condition is not met, we will send 0 instead. 0 V1005. We might also declare this V1005 so that it is a bit more organized. So we will call it temperature send to PLC 2. Okay, so we have our two sub-programs created. Now we have to call both of them in the main program. So append, call, and first we call scale function, scale temp, then we'll call in-out program, and as you see we have parameters that we must assign now, x0, x1 and y0. Okay, so our program is ready. We'll save it. PLC1, save, and let's try to get connected to our PLC. So we have two options, serial port or TCP/IP. We use TCP/IP in our case because we are internet connected. Our module was pre-addressed, so we're trying to search for it, and it is accessible. So we're not connected to PLC. So what we must do now is to download our program. So we press download and download. Program download completed, so we might start monitoring. So now we are online with the PLC and we monitor all the values or all the program inside. So if we open scale, we should be able to see already, yes, we see that our temperature is just about right. For the test, I will start warming it up with my hand just to make sure that it's increasing. It does. So, okay. We have PLC program ready. So the second part would be to read this value in the second PLC, PLC2. So to do that, we will stop monitoring, disconnect from the CPU create a new program. Second CPU, it will be T series T16SOT. We will call it PLC 2. Create main program. Hardware configuration is done already because we have only CPU, no modules. So maybe we'll start with creating tags. We know that we will need a help bit, one for confirm that we have successful reading, and the other one will be actual temperature from V1. So let's say it will be V1002, temperature from PLC 1. Okay, so we go back to project manager. So we must declare our Haiwellbus read table. We'll call read from PLC 1. Okay. So component read from slave. So we are going to read V1005 and we'll put in V1000. And since the data we are going to read is a floating point, then we must declare two registers. One. Okay, so now we have to use function to read Haiwellbus via TCP. So it's this function. So we are going to read from IP address 111. Table name is called read from PLC 1. And yeah, just to have program a bit more visible and organized, we will use a move function, floating point move. So we will move F1000 to our created tag, which is V1005. Okay, save the program. We'll call it PLC2. Okay, so we'll try to go online. We know it's 112. Try to search it, we found it. Load to the CPU. We have some warning. So we have to check. Oh yes, we didn't declare the output. M0. So once again, download. Now it's okay. And we start monitoring. So as we can see, we are getting 0 now because our start button wasn't pressed. So we'll press start button now. And as we can see, we can read 22.5, and if we press stop sending, we're getting 0. I press push button again and try to warm up our sensor. Yes, so the value is correct. So this was in a nutshell how Haiwellbus communication works and some basic functionality of Haiwell Happy software. Thank you very much and see you in next video.